So still on the properties of indices, we are looking at my Cs1, which is my Cs property, which I call fractional index. So this, if for instance I have a raised to the power half, this according to this property is saying that there's any number raised to the power that is half, this is equals to the square root of that number. Square root of that number. So it was a raised to the power half. So this is the same as root a. So if I have 2 raised to the power half, this is the same as square root of 2. If it is 2 raised to the power, let me use 16. Let's say 16 raised to the power half. This is the same as square root of 16, which is equals to 4. Again, if it is a raised to the power 1/3, this row is saying that this is equal to the cube root of a. So if I have, for instance, 8 raised to the power 1/3, this is equal to the cube root of 8. And from our sets, cube root of 8 is the same as 2. Again, if I have the cube root, or let's talk about 125 raised to the power 1/3, this is equals the cube root of 125, and this is equals to 5. Now, if it is a raised to the power 1/4, this is the same as the 4th root of a. Meaning, if I have 16 raised to the power 1/4, this is the same as the 4th root of 16. And the 4th root of 16 is 2. Again, I can say 81 raised to the power 1/4 is the same as the 4th root of 81, which is the same as 3. So in general, when we say a raised to the power 1/n, then per this property, this is the same as the nth root of a. So a raised to the power 1/n is the same as the nth root of the number. Now, what if I have this particular statement, or if I have a raised to the power m/n? This can be written as a raised to the power 1/n or raised to the power m. Remember, m/n is the same as m times 1/n. So now, this particular expression can be written as, we know the 1/n is the same as the nth root of a, then all raised to the power m. Somebody could have also written a raised to the power m/n as a raised to the power m, all raised to the power 1/n. So when you simplify this, then you get the nth root of a raised to the power m. So these properties, you play around them and they can even give you different properties. So if I have, for instance, if I have 2 to the power 2/3, this can be written as the cube root of 2 all raised to the power 2. Or I can write this as cube root of 2 all squared. And these two will give us the same answer. So, having done discussing the laws and the properties of indices, join me in my next video as I take you through examples and problems involving indices. Thank you for your attention.